What is the potential of educational neuroscience? British physician Ben Goldacre says, "I think there's a huge prize waiting to be claimed by teachers. By collecting better evidence about what works best and establishing a culture where this evidence is used as a matter of routine, we can improve outcomes for children and increase professional independence." Welcome back to the Neuroscience Meets Social and Emotional Learning podcast, where we bridge the gap between theory and practice with strategies, tools, and ideas we can all use immediately applied to the most current brain research to heighten productivity in our schools, our sports environments, and modern workplaces. I'm Andrea Samadi and launched this podcast almost 4 years ago to share how important an understanding of our brain is for our everyday life and results. This season, Season 9, will be focused on neuroscience, going back to the basics for the next few months, as we welcome some phenomenal pioneers in the field of neuroscience, paving a path for all of us to navigate our lives with more understanding with our brain in mind. My goal with this next season, that will run until the end of June, is that going back to the basics will help us to strengthen our understanding of the brain and our mind to our results and provide us with a springboard to propel us forward in 2023 with this solid backbone of science. For today's guest and episode number 269, I've been waiting to have on this podcast since I came across his work in the field of educational neuroscience around the time we interviewed Dr. Daniel Ansari back in June of 2021 for episode 138. I saw their annual research review, and it was called Educational Neuroscience Progress from April 2019, written by Michael S.C. Thomas, Daniel Ansari, and Victoria C.P. Roland, that provided a thorough overview of the origins of educational neuroscience, outlining where it began, the challenges it faces as a translational field, and addressed its major criticisms. I immediately wrote down Michael S.C. Thomas's name, along with his email address, to reach out to him to learn more about his perspective in this field. Since I was interviewing Dr. Daniel Ansari at the time, it brought something to light for me that the people who actually write these research reports that we find on PubMed.gov are working hard somewhere and not completely out of reach if you really want to find them and ask them some questions about their work. When I finally emailed him, I was thrilled to hear that he had a new book, Educational Neuroscience, The Basics, and I'm so grateful to have this opportunity to speak with him about this new book. Before we meet our next guest, Michael S.C. Thomas, let me orient you to his work. Michael S.C. Thomas is a professor of cognitive neuroscience at Birkbeck University of London. Since 2010, he's been the director of the Center for Educational Neuroscience, a cross-institutional research center which aims to further translational research between neuroscience and education and establish new transdisciplinary accounts in the learning sciences. In 2003, Michael established the Developmental Neurocognition Laboratory within Birkbeck's world-leading Center for Brain and Cognitive Development. The focus of his laboratory is to use multidisciplinary methods to understand the brain, including behavioral, brain imaging, computational, and genetic methods. In 2006, the lab was the co-recipient of the Queen's Anniversary Prize for Higher Education for the project Neuropsychological Work with the Very Young, Understanding Brain Function and Cognitive Development. Michael is a chartered psychologist, fellow of the British Psychological Society, fellow of the Association for Psychological Science, senior fellow of the Higher Education Academy, and board member of the International Mind, Brain, and Education Society. Let's meet Professor of Cognitive Neuroscience, Michael Leslie Thomas from Birkbeck University of London, and see what we can learn together about educational neuroscience, the basics. Welcome, Michael. Thank you so much for sticking with me to make this interview happen. I've been wanting to speak with you for years. Thank you so much. I know how important this topic is, and I appreciate you being here today.
It's a pleasure, and thanks so much for inviting me.
Wonderful. Well, Michael, I want to get right into how did you find your way towards studying the brain as it relates to our educational system and establish the Developmental Neurocognition Laboratory within Birkbeck Center for Brain and Cognitive Development? That's quite a mouthful right there.
A lot of academic stuff there. So I mean, it's a bit of a torturous route, but it actually started off when I just left school, and I was working for actually an electronics research firm just for a year before going to university. At that stage, I was on an engineering track, and in that year, I was starting to think about computers and whether computers could think and whether computers could ever get to be conscious. And that started me off on a drift towards psychology eventually. I got into psychology, and again, I was trying to understand, well, how does the mind work? Is it like a computer? Is it not like a computer? Does it matter that we're doing thinking with a brain instead of a computer? So yeah, I ended up going into psychology. I started off doing some work in bilingualism, actually, how the brain processes two languages at once. And from there, I did some work on neurodevelopmental conditions like autism and dyslexia, which gave me a perspective about how minds and brains could work differently in different people. But it was all pretty much basic research, and it was only as I started to get a better idea of how the brain works, I was thinking, some of this information's got to be useful in education, right? I mean, the more we understand about learning mechanisms, some of this stuff has to be relevant for teachers. So that got me into this sort of more translational area of education and neuroscience. And we set up the University of London Centre for Educational Neuroscience back in 2008. So that's been running about 15 years now. And it's a long journey trying to think about how basic research can be useful for educators and practitioners in the classroom.
Now I'm going to get into some more in-depth questions on the research because I do want to dive deeper into the difference between evidence-based and neuroscience-based. We're going to kind of go a little bit deeper here, but I saw your website unlock.org. So not only are you looking at how the brain impacts the learning in the classroom, but you're actually doing studies, randomized controlled studies. Can you explain what you're actually doing with the work there, the research behind it?
Yeah, so very, very happy to talk about Unlock. That's a particular project we've been involved in. That is, in fact, a project which I think is a nice example, will end up being a nice example of how you can start with just a classroom challenge, a problem that teachers are observing, and think about how you can use neuroscience to shed some light on what's causing that problem for students. And then go from that to some new learning activities that might be more effective. But then how do you check they work, right? How can you be sure they work? To do that, you need evidence. You need to structure trials. Trials need control groups to check that your new learning activity really works. And that's the final phase. We've been going about 10 years on that project. Eventually, I have ambitions of turning this learning activity into a tool that teachers might actually want to use. And that requires more kind of product development and commercialization. But yeah, I can quickly summarize this particular project. The problem that teachers were observing was when children learn about science and maths, they can come across some counterintuitive ideas or concepts. These are concepts that don't really fit with your everyday experience. So, for example, Children grow up, they kick a football, a soccer ball around, and on a field, they're used to the world being flat, right? Your football pitch is flat. The world seems flat. And then you go into a science class and you're taught that the world is round. It's a globe. The surface is curved. But that just doesn't fit with your day-to-day experience. So in some sense, that's a counterintuitive concept. And there are other aspects of science, like dolphins, for example. Dolphins are mammals and they breathe air, but they look exactly like fish and they seem to behave like fish. So how do they get to be mammals? How are they more similar to a cow than a shark, for example? All these kind of things that don't quite fit, they don't quite work. But yet when we are trying to teach children that the world is round, we don't want them to go out of the classroom afterwards and start playing soccer differently, as if the pitch was curved. So you have to keep your intuitive knowledge, but you have to learn your scientific knowledge. So if we go into the neuroscience, it looks like a key part of learning counterintuitive concepts is sort of suppressing or inhibiting your everyday experience to allow you to develop and learn your new science concepts. So this suppression or inhibition is part of cognitive control. It's part of an activity that the front of the brain does. So we thought, okay, so this is a skill that children need to learn about these strange, inconsistent ideas. Can we develop a learning activity that would actually help them develop that cognitive control skill? So that's when we sat down with teachers and thought about how could we develop a learning activity to improve your inhibitory control, is the technical term. And that led us to develop a computer-based activity, a game that was a little bit like a game show, where a host asks these sort of difficult, challenging questions, but they insist that all the pupils or the players in the game have to stop and think, have to pause before they give their answer. And so we were trying to help children control the kind of ideas that came to mind to suppress the initial impulse to help them acquire these counterintuitive scientific and mathematical concepts. So from there, that's just the idea. And then you have to develop a learning activity. You have to work with teachers that it's useful and that they can use it in class. And then you have to actually run some trials, some evaluations to check that way of learning science, maybe 15 minutes at the beginning of a science lesson, a couple of times a week for a term. That's actually going to produce better end of term performance on your science assessments. So yeah, we ran that assessment. Again, that took maybe a year to do, 6,000 children. Oh. We did that with 8 and 10-year-olds, having a look at their science and maths learning. And it was effective. It was more effective than science for maths, but particularly we were excited that it seemed to work more strongly with maths for children from poor backgrounds, which is a particular current aspect that we're very interested in helping kids from poor backgrounds, particularly who have fallen behind during the pandemic, to catch up, and what kind of learning activities might help that. So that trial was successful. We're now running. It's a bit technical, but first you need to check that these methods work under ideal circumstances, and then you need to run it all again a bit more hands off and let the teachers get on with it. It's a bit more naturalistic, everyday conditions, and then you need to check that it still works kind of in the wild. And that's the stage we're at on that particular project.
Well, I know how intense it is to have an idea and then get the research or the evidence behind it. So I think congratulations on that, because there's so much involved. I've actually sat with someone in my office trying to look at my statistical means to see if I can prove efficacy with my programs. And I just didn't have the 6,000 students to do it, but I know the work that went behind that. So congratulations, that's huge. And so then moving into now your book, Educational Neuroscience, the Basics. So that's why we're here today. When I saw your research paper back a couple of years ago, I thought, well, is there actually a person behind this research paper, and what are you doing in England? So it's just fun to get here. And then I saw you'd actually written the book with Kathy Rogers, who moved to the field of neuroscience after years of producing television shows in science. So I can only imagine what her background in television and film has done to your work. Can you just share what she might have brought to the vision of this book?
Yeah, so Kathy's had a long and varied career involving. She started out in pop music, I think. She was in a band you can find on her website, and then she went into media, and she was a TV presenter for a while, and then moved into TV production, particularly science documentaries. But through some iterations of doing that, she got a little bit frustrated at talking about science and wanted to get more involved in doing science. So she did a PhD in my lab, and she was focused on children's creativity, how children become more creative as they're in the mid-childhood, and perhaps it reaches a peak, and then they get more conventional in their thinking later on. And Kathy was particularly interested in how if you encourage children to focus more on tasks, so there's something called executive functions that sometimes we're encouraged to train our children to be better on, to have better kind of attentional skills. That maybe the more we train that focus, that's at the expense of creativity, because creativity is a little bit about letting your mind wander and view either side of the path, as it were. So Kathy got into that, did some excellent work with young children, looking at the development of their creativity skills and where their ideas come from and how they use their ideas. I think towards the end of Kathy's PhD, we were talking about the possibility of trying to combine her skills in communication and the media with some of the science that she was coming across. And I have another broader project, a book that I'm working on right now, which is called How the Brain Works. Some sort of basic principles of brain function, which are not too technical. And we try to use some of that material to shape that into a message that might be useful for teachers. So it was a really enjoyable collaboration of the science and the communication. I think almost for me, this is the book that just came out just a couple of weeks ago. For me, it was like a key point in working in this field of education and neuroscience, of trying to think, what is the message that teachers should take from neuroscience? Because neuroscience is a very technical field. It's neurons in petri dishes, it's chemistry, it's genetics, it's brain imaging, it's animal research. There's an awful lot of stuff going on, and we don't want teachers to be reading scientific journals and so forth. Somehow we need to boil down that message. And these days, I think about the goals of educational neuroscience as having three parts. For teachers, we need to think about, well, what is the gist of how the brain works? Second, if the brain works like that, what are the implications for what that means for students learning in the classroom? And then the third part is what you might call implementation. How do you use those implications in a way that's actually useful and will actually work, say, in a classroom where a teacher is, I don't know, trying to get 36-year-olds to get changed into their PE kit. I mean, that's an everyday classroom. How a neuroscience principle is going to work in that situation? So almost for me, this book is a landmark of thinking, how do we boil down the message? What are the key parts to take from neuroscience that will be useful for teachers, and put in a way that's reasonably accessible? So with Kathy's help, I think we're finally getting closer to achieving that.
Well, this is exciting. And so when I first came across your work, when I interviewed Dr. Daniel Ansari, did you know him when he was over there? Did you just work on projects together? How did you come?
We worked in the same lab. I mentioned that I did some research on developmental disorders, and I was in the same lab working for an eminent professor called Annette Karmeloff-Smith, and I was a postdoc, and Daniel was a PhD student in the same lab at the same time. So we worked together.
Very fun, because after I left England when I was little, I moved to Canada. So when I saw he was in Canada, I thought I've got to get him on. And then I saw he mentioned all the research he'd done. And then I saw your name with Victoria Noland, and I often do not sit around reading PubMed articles. I find them very challenging, but I saw the one that you'd written. And then I saw that there was criticism in the field, and I had no idea. This was before I knew about the reading wars. This is just new in the past couple of years that I learned that whole angle of the brain. And so I wonder if you could bring our listeners up to speed, because I had no idea that there was criticism. And you say that this field is barely out of the gates. Where did it start, and where do you see it's going?
Yeah, so where it started was really in the 1990s, and it was technology driven. So driven by innovations in technology. So in trying to understand how the human brain works, through a lot of history, that's been quite hard to work out, right? I mean, we can observe behavior, we can look at what people find easy and hard to think about and do. We can try and figure out like sort of some kind of task analysis that, you know, in there somewhere must be an attention system and a memory system and these kind of things. And we're just trying to work that out from the outside. And then we have evidence from what's called neuropsychology, having a look at people who've had brain damage and understanding what skills can be lost. So if you damage a bit in the front of the left of the brain, you can, as an adult, you can lose the ability to produce language. So probably that tells us there's some kind of language system in the front of the brain. But it was in the 1990s that we developed brain imaging technology, where you could actually get some insight into the functioning of the brain in vivo, as it's working in people who are behaving naturally. I mean, not completely naturally, because you put them in a brain scanner, right? But you can see the human brain in operation. None of these brain imaging technologies are perfect. They will give you bits of information about the brain. There's a wide set. Some of them focus on electrical activity coming out of the brain, some of them about blood flow and energy use inside the brain and so forth. But it's all these new technologies that begin to give us a better insight into how the brain works. And it was really in the 1990s that people started to say there's a big acceleration in then what was christened the decade of the brain. We're understanding more about brain mechanisms of learning. And I think there was a little bit of a sense of the field trying to run before it could walk, and arguments that already we could see that there were. So I'm going to put all of this in like inverted commas, so I don't necessarily agree with this past, but the early arguments were that there were critical periods in brain development, that the early years were super important, and the neuroscience supported that. That was when the brain had the most connections. And so educators should focus all of their resources on early years education. And this really strongly influenced the Clinton administration to change educational policy. So very early on, there was a translation from neuroscience into high-level government policy. And there were some detractors who I think quite fairly said, hold on a minute, that is a big stretch of the imagination. We do not really understand in enough detail yet what's going on in brain development and brain function to make these hard and fast recommendations. So I think everyone had to sort of stop and think a little bit more carefully about how we do this. The way the brain works is very complicated, right? And neuroscience is telling us about kind of moment-to-moment activities, how you use certain kind of perceptual information to drive certain kind of motor action. That's what it's really good at. But we have to get through all of that to understand about, say, how you teach a science curriculum so that your students can pass end-of-year exams. And that's a whole different level of challenge, right? So I think there's a lot more neuroscience to be done and a lot more translation of that neuroscience into bits of information that not just potentially useful to teachers, but that we can work with teachers to understand how those kind of insights are going to be useful. There's some other distractions going on. Scientists are, let's just say they have some limitations sometimes in getting their message across. So there's a whole field sprung up of what's called neuromyths. This, misunderstanding of thinking, perhaps humans only use 10% of their brain to think. I mean, that's been built into the plot of Hollywood films, right? Or you have left brain thinkers and right brain thinkers, or that boys and girls think differently. There's a lot of these things that turn out to be mythical, a misunderstanding of often some bit of research has supported that, but the way the information has got through to the public consciousness is misconstrued. So that's like a science communication problem, and we need to sort that out. There are some people in education who say the brain is just the wrong level of description. It's too detailed. At the very least, we're dealing with whole people, and really we're dealing with whole classrooms and kind of social interactions between teachers and students, and education is something about society. So they think you have to stay at the high level. So there's some kind of resistance to that. And then we have this other challenge that there are always enterprising companies out there who think they might shift more product if they have the word neuroscience in it, like brain training techniques. Pay me $10 and do this activity. It's endorsed by neuroscientists, and it'll make these kind of things. So there's quite a lot going on, but I tend to take a kind of cautious, evidence-driven approach of thinking this is a marathon, not a sprint. Let's build the evidence base. Let's understand what it means for the classroom. Let's work with teachers to think about, in a small way, how we could offer some helpful suggestions.
Yeah. Well, your book actually helped me set the stage for the year, and I labeled my season Going Back to the Basics. Right. Just after your book, just thinking I'm not going to talk about anything else that's not back to the basics, because I didn't know about all of that background. I came in with the excitement, and even starting out reading the beginning of your book, it's got a quote from British physician Ben Goldacre, who says that there's a huge prize waiting to be claimed by teachers with this book. So that's kind of what I saw. I saw this as, well, something wasn't working when I was a teacher in the classroom in the 90s, standing there and my students were misbehaving behind me. What was I missing? Was it that I wasn't connecting with them, or where was I going wrong? And I thought this has got to be something to the answer to that. So what do you think would be your goals now with this book? And how do you see it improving outcomes for students, thinking of all the teachers in the classrooms that it's not working? How's this going to help them now?
Okay, so I have to be modest about the aims here. This isn't going to revolutionize education per se. And I would say that teachers are the experts in the classroom. So it's not like scientists are going to be telling teachers how to run their lessons. And neuroscience is only a small part of the picture there. So, learning is only a limited part of the picture of what education is about. Who decides what education is for, what we should teach, how we should train teachers, how many teachers we should have. So there are big issues, so modest in our focus. But if you think about how the brain works, ultimately learning has to be done in the brain. No learning is going to happen without brains. So it's one part there. But if you can think about just the very simple take-home message from the book is that the brain, it works the way it does because of biology. And the biology works the way it does because of evolution. So we've come from some long history, and that has put sort of constraints about what brains are for and how they tend to work. So you can think about that in terms of what the brain's priorities are, what's most important for it, based on this big kind of biological history where it all came from. So number one priority for the brain is movement, right? You need to use your sensory information, bring that all together to make the correct next action. Okay, so it's very in the moment. Yeah. Number two priority is emotions. So to meet your emotional goals, are you scared? Are you happy? You want to do nice things? You want to make friends and not be too hungry or thirsty and get to sleep. Some basic kind of needs that you have. Number three goal, we're social primates. A lot of the brain is dedicated to processing information about other people. The people sitting next to you, are they your friends? Do you like them or not like them? Are they looking at you? Is the teacher looking at you? Are they looking out of the window? And so forth. So you're concerned about other people. So those are the top three priorities about what the brain is doing moment to moment: movement, emotions, other people. Now, all the stuff we're trying to teach in school, all those skills are what you would call cognition or thinking. That's the fourth priority, the fourth least important job for the brain. So the very simple message from that is you don't want the other three priorities to get in the way of learning. Okay, so you need to have the right sensory environment for the kids so that they're not distracted. You need the emotions at least not to get in the way. So you don't want kids to be anxious or fearful about learning. You want them to be enthusiastic and curious. And you don't want them, they're going to be thinking about their friends. You don't want to use that. Social priority is that they want to impress their friends by misbehaving in the back row. You want to use peer pressure, as it were, that they want to impress their friends or work together in groups. You want to harness that social influence in the direction of learning. So if you can line up all those other priorities, the physical environment that kids are working in, their emotional goals, and how they're working with other people and their relationship with the teacher, if you can optimize all of that, then it will maximally support your learning goals to learn about your particular topics in the classroom.
Well, you just brought everything together for me, because I've been practicing the questions and they're all outlined to cover the top three. And my last one goes into understanding thinking. And I was trying to get a gist for this. Like if I was to draw a diagram of what we're trying to do here, and you've just done it right there with the three, and the goal is thinking. And so we're going to get there, but I'm just really excited at this point because this is when the aha moments come in. And so now I think about, I want to just bring in the graphics that I've seen along the way of trying to understand how we're going to do this. So I've seen ones that have neuroscience or, consisting of the brain and learning. And then we've got psychology, and then the pedagogy, and then we've got neuro education in the middle. And then, so I know your background with neuroscience and then psychology. How would you draw these three this graphic to explain what you're doing with neuro education?
Yeah, I've seen a lot of these diagrams too. I don't agonize about the definitions, as it were. We have various debates about whether what we're doing is interdisciplinary work, multidisciplinary work, or transdisciplinary work. And I'm guessing in the detail, maybe some of that is important. I like to think of this as more kind of practical, that we've got a goal in mind. And I know academics like to have some kind of hierarchy of science, but I tend to think about more of this as like you're an industry, right? So you've got some problem to solve, and I don't know you've got a gorge and you need to build a bridge across the gorge or something. You want to bring together a crack team of people who have a diverse set of expertise and those guys need to work together to solve the problem. And it's not somehow like, some guy is going to design the structure of the bridge and some guy is going to be a materials about what should it be built out of, and neither of those guys is more important or less important than the others, but they, bring your best guys together and try and crack the problem. So I mean, very broadly, the diagram I'm guilty of is thinking broadly that there's two routes that link neuroscience and education. And one of those is like an indirect route. The neuroscience will mainly work with psychology to improve psychological theories of learning. And then the new psychological theories will then inform education. So in some senses, you're not going directly from some kind of brain scan results and then telling teachers, so you should be doing this instead of this. I don't think that's ever going to work. We need to digest neuroscience findings to make them usable. But I would also argue for a direct link that goes straight from neuroscience to education that doesn't involve psychology. And this you might think of more in terms of brain health or brain optimization, that the brain is a biological organ, and we are understanding a little bit more about how to put that brain in the optimal condition to do what it needs to do. So some of these things are about diet and about reducing stress and about physical fitness and the role of sleep and so forth. So it's trying to make sure that when a child enters the classroom from a metabolic, physiological point of view, that their brain is in the best condition to do the learning they need to do. So those are the two kind of types of interaction that I would see between the fields.
Got it. And that does make sense. And I feel like you've answered my next question. So I'm just going to read it and then see if I've got the understanding right, because we've gone back to the basics here with your book. And I try and think about this like, not just the classroom, but I'm thinking about sports environments or the workplace. We always go back to the basics to strengthen our skills. And so my question was going to be, why do we need educational neuroscience to become better teachers? And I think the answer is because with those 3 steps that you just said, we are working on improving the students' sensory experiences, making sure they feel safe, and then addressing their social, making sure they're curious, and then that bolsters their ability to think and learn. Have I got that right?
Yeah, pretty much. So I've had quite a lot of experience of talking to teachers about, evangelizing about why I think neuroscience understanding is good. And a frequent experience is at the end that the teachers ask questions, something around, so what should I be doing different on Monday morning? Give me some tips about stuff that I can do that's going to be really useful for a month, that's going to improve my students' outcomes. And, I'd like to do that, but part of me thinks that tips are the wrong way to go. Tips for teachers about what they should be doing is the wrong way to go, because ultimately, 2 problems. They're disempowering. They're kind of prescriptive, and I think teachers should be making they're the experts in the classroom. They should be making the decision about what best works for their pupils. But secondly, there is no tip you can give in any part of learning that is always going to work for all children in all circumstances. It's going to work sometimes, it's not going to work other times. So if you have some tip that you've been told by some person that's going to work, and then you find it doesn't work, you're just going to lose confidence that, that guy doesn't know what he's talking about. I much prefer to try and get across why does that work? What is the reason that practicing retrieval of information might help memorization? Trying to get across the why does it work? Why does the tip, why would that be useful in the first place? And trying to give teachers a gist of how it works, why it works that way, And then the teacher is then empowered to think about, okay, so I'll use this technique, but here's how I can adapt it for my particular pupils and my particular, learning goals for a given lesson, to give the teacher more power to see when a technique is likely to work and when it's not likely to work. So that's why my push is to get across a gist of how things work rather than go down to the detail of very particular tips.
Got it. And going into the research again, I'm going to circle back to the area where I wanted to start with the distinction between evidence-based and neuroscience-based, because to get grant funding or to get any type of funding or to get a program in the schools, it's got to be evidence-based. And there's a lot of controversy around that. I think a lot of people don't fully understand what's evidence-based and what is neuroscience-based. So could you explain the two?
Yeah, so neuroscience-based would be a particular type of evidence. But I would see neuroscience-based as feeding more into an understanding of how it works, how learning works in the brain. And not, it's a different type of evidence from you're using some kind of technique in the classroom. Are you using small group teaching, one-to-one tuition, whole group, whole class teaching? Which of those works better for your topic? How would you answer that question? What is there actually evidence that the approach you're using is effective? Who collected that evidence? How did they design the trial? Was it with a couple of classes or was it with 6,000 kids? So that kind of evidence approach, how do we know that some technique in education works? So that is the broader kind of evidence-based approach. I would be maybe sometimes a little bit cautious about the term evidence-based. Not everyone loves that. I think sometimes it's better to use the term evidence-informed, because not everything needs to be driven by the evidence. You need to have values in there as well. And the values don't necessarily come from the evidence. So what is it that we're trying to achieve as a school, as a community, as a society? These are where our values come from. And then how does the evidence feed into what is the best way to achieve those goals? So I prefer to think in terms of evidence informed rather than evidence-based. I would say, again, neuroscience, there can be distracting parts when people say, as we talked about earlier, these kind of brain training approaches, and it's as endorsed by neuroscientists. That's a different kind of slightly distracting thing. And in fact, some academics have written about something that they call the sane effect, the seductive allure of neuroscience. And they've suggested that if you've got some new educational technique, if you put a brain image in there, that people are more likely to believe it. And that may well be true. That's kind of a contextual framing effect that advertisers love and terrific, but that's nothing to do with what we're trying to do in educational neuroscience, which is to understand mechanisms of learning in a way that's useful for teachers.
Definitely. And so then when I read that survey that you talked about with teachers, it was from Wellcome Trust from 2014. And this survey found a high level of interest with neuroscience. Like, everybody wants to know what's going on with the brain and learning. And I can even tell by the numbers of this podcast, people that are downloading in 168 countries. So there's a lot of interest. People want to know this subject. And they said they knew little about how the brain works because we weren't taught this in teacher training or in school. And suddenly we're faced with, like, what is this? And so there's this unmet appetite for neuroscience knowledge, which, just reminds me of why I started this podcast in the first place, to bring together all the leaders that have the background and research and expertise. And so I know that in the US here, we have an organization called CAUSL, and they govern social and emotional programs. They have a rating system. Is there any sort of system you know of that says this program is evidence-based or evidence-informed? How do you know if the program you're using is going to work, or is it lacking efficacy? How do you know?
Yeah, I would say that we're still in the kind of early days of getting to that. To have some official kind of kite mark to say that this is properly a sort of evidence-based approach, or supported by the neuroscience, we're not there yet. I know it is a movement both in the US and in the UK to try and bring together evidence base. So in the UK, we have the Education Endowment Foundation, which is an organization spun off from our government Department for Education. And in the US, there's the What Works Clearinghouse. Yes. And these are organizations who are trying to compile the evidence base where trials have been run to see what techniques are effective. So I think that's part of it, trying to pull together the evidence and identify areas where we don't have evidence. Part of it, I think, is to think about teacher training and trying to get a little bit more neuroscience into that. Doctors go through a lot of training to know how the body works, and that feeds into the relationships they have with their patients and the kind of treatments that they prescribe. You wouldn't be happy with a doctor just sitting there with a big manual. You tell me the symptoms, I'll look up in the manual what the treatments are. I have no idea how your body works. I just have this big, set of, and down the corridor, they're using this technique. It might work. I don't know. I've not seen the evidence. I don't know how your body works. That wouldn't fill you with confidence. Now, public health and education are not directly parallel to each other. It's much more obvious in medicine. You're healthy or you're not, and the goal is to be healthy. Whereas in education, it's not completely clear the pathways we need to take and necessarily the outcomes we want to achieve. But I think some deeper understanding during training, teacher training, something about neuroscience and mechanisms, and maybe a little bit about, or how could I tell if this technique I'm using works or not? Where would I look for whether anyone's actually evaluated this? That kind of awareness, I think, is a goal or an aspiration we would have in the future.
Yeah, definitely. I think back to Dr. Daniel Ansari's interview. He said that he'd like to see a bridge in all the schools with someone that connects the research to the educational system. Like now in the US, we have these social and emotional learning coaches or positions that have come along the years along the way. And he saw something like that for neuroscience. Do you think that there needs to be some sort of bridge connected to the schools that bridge the gap with this type of knowledge?
Yeah, for sure. I think there needs to be a way to communicate, to digest basic research in a form that's useful for teachers. And I think having one member of staff in each school who is in contact with research and can be monitoring the latest happenings, but also from the research end of you need communicators who are pulling out of the latest research which parts of it may be important. So I think that kind of bridge has several supports in it. But I also like to think that researchers don't necessarily know that they're investigating exactly the right things, and there needs to be communication from the other direction, from practitioners, from the classroom, trying to encourage researchers to focus in certain areas on certain kinds of challenges. So I think more in terms of an ongoing dialogue rather than some other basic research just conveying the truth which teachers need to know. I think a lot of the time, researchers need to be pushed towards the most relevant questions.
Definitely. And so as I was getting through the book, I loved that you quoted David A. Souza. We've had him on the podcast twice, and his How the Brain Learns system. It's usually behind me somewhere on my bookshelf. But it was the first book that was handed to me when someone said, you've got to understand how the brain works. And it was an educator that was going to be using the programs I'd created for leadership and character. And he said, here, read this. And I opened it up and I saw the memory graph, how the memory works in the brain. And I thought, this is way too much for me to understand. But you talk about the quote that he says that teachers are the only people whose specific job is to change the connections between neurons in the students' brains. And so this is something we should try to figure out if we can. So where should someone begin so that they don't get intimidated by opening up a book and seeing a big graph of how the brain works? What's the basics of neuroscience that we should all start off with that you outline?
Well, it's a big question. And that's what we're trying to do with the book, some kind of friendly introduction that doesn't launch you straight into images of the brain. I find neuroscience often quite inaccessible because a lot of it, if you're taught about neuroscience, focuses on the naming different parts of the brain. Right. And often they have kind of strange and arbitrary names. And then a lot of it is about the methods that neuroscientists use, you know, how brain imaging works and single cell recordings, and then you're down in the physiology about understanding about voltage potentials and sodium channels and so forth. And that all feels very inaccessible. As I said earlier on, I think teachers need a much higher level view about broadly how the whole system works. And I think in some of the work I've done, I've just started off by posing some unexpected things about the brain. And you know, ask yourself, why is it that do you know what the capital of Romania is offhand?
No.
You know, it's either Budapest or Bucharest, all right? Bucharest.
Okay.
But that's something you can forget easily, right? Yeah. But if you're scared of spiders, you don't ever forget that. That doesn't slip your mind. Why is it that you forget the one thing but not the other thing? Now, kind of like a puzzle. That's if you just have one memory system, why wouldn't you forget everything equally? So something is clearly going on there. And then another one. So let's say I do a test and I get 7 out of 10 in the test, right? Now, if I was hoping to get 9, I might be really disappointed by that. But if I was happy with getting 5, I might be really excited by getting a 7. So isn't just scoring a 7 a 7? You've got 7 out of 10. Why do your expectations matter so much about how happy or sad you are? Again, that tells you something about how the brain is working, its particular kind of priorities. I'll give you another example. If there's a really unusual piece of information, so I don't know, you're required to learn the name of the new Russian president. Okay, I don't know who that is, but it's, you know, Russian pronunciation. It's not familiar to me. I find that quite hard information to memorize. But if something really unusual happens to me, so I don't know, I see the ghost of Elvis Presley riding a horse down the high street, I'm never going to forget that. That is going to stick in my memory. So somehow unusual events stick in our minds, but unusual information is quite hard to learn.
Oh,
it's easier to learn information that fits, is consistent with what we already know. And again, that's telling you, well, there's got to be more than one memory system in the brain, or something's going on there. So there's a variety of those kind of, wow, the way our minds work does look like it influences what's easy and what's hard to learn. So I think that you start off from that end of setting puzzles about strange things about, you know, why do you need to sleep? You know, why? That's a really kind of strange thing. You have to hide yourself away for a third of your life. And sleep also seems to be quite important for learning. You do experiments showing that over the same period of time, you learn information better if you've had a sleep in the middle. why? I mean, that's pretty arbitrary, right? So all of these, you start off with these puzzles and then begin to understand, well, what are the main principles of the brain? What kind of learning mechanisms does it have? What kind of information do they need to be fed to optimize? And then that gets you further into understanding the implications. So, it turns out you're learning information, let's say in two different topics. It can be quite useful to mix up those bits of information, to move between, or do a bit of maths, I'll do a bit of science, then I'll do a bit of geography, a bit of history, but I'll mix it all up. That actually works quite well. If you're trying to learn a new dance move, don't mix it up with another dance move. You'll get yourself hopelessly confused. So if you're learning procedures, automated skills, you need to learn those in blocks. So again, it's, starting off from the goals of learning and the kind of idiosyncrasies that we seem to show in learning. And that's your starting point to then understand, well, how many memory mechanisms are there? And okay, they tend to sit in different parts of the brain, but, we can get to that later. Let's just think about what are the principles of function. So that will be my way of getting into neuroscience, is not to start with a picture of the brain and a lecture on how an MRI scanner works, but to think about, principles of function and how they impact learning.
Well, I could talk for a week on everything you've just said there. And I know that we're kind of coming close to the end of the hour here. So I'm just going to go into a couple of things you've said, because I've always wondered what makes something unforgettable. So you had a diagram in the book that talks about things you might forget and things that you'll never forget. And you just talked about it. Maybe we forget about the capital of certain places, but you'll never forget about that ghost. And you had this diagram of Paddington Bear in the book, and you talked about it with your grand's 80th. And then I just remembered getting a Paddington Bear in the mail when I was a kid. And I remember the shiny blue boots, and I could smell the boots and do up the jacket, but I couldn't remember what the hat was like. I thought it had to have been blue. And then I'm thinking, is Paddington Bear's hat blue? And I'm going to Google and I'm thinking mine definitely had to have been. So why do we forget some things and other things from 40 years ago are unforgettable?
Yeah, so generally the answer is different memory systems. Okay. So episodic memories, of momentary experiences in our life history, they are encoded in the hippocampus. It's a particular structure that likes to do snapshot memories, and it kind of date stamps them. And those memories, they stay in the hippocampus for about 3 months. And then they get shipped out and stored somewhere, and you'll have selected out some of the most emotionally salient memories or memories that are connected with rewards for good or bad. Those will be the ones that finally get retained. In the conceptual memory, our understanding of facts and knowledge and systems. So that, Paddington is a bear and he comes from Peru, and his, bears tend to have fur, and fictional bears like marmalade sandwiches and these kinds of things. This is stored in a network, which is not just a set of individual memories, but a set of kind of general categories and relationships. And to build that kind of knowledge, you sort of layer lots of memories on top of each other. And when you put all the memories on top, you kind of get this pattern emerging of generally how things work. So that type of memory, you're continually getting overwriting and interfering. And if you don't use that knowledge, it tends to fade away. So conceptual knowledge, fact knowledge, that's kind of a slightly more use it or lose it. We have procedural knowledge. So this is tying your shoelaces. That stuff tends to be hard to acquire. Takes a lot of practice to be expert at, learning to ski or riding a bicycle. But once you've learned it, it is pretty robust. If you don't have a skill like that, it kind of gets detuned a bit. But it doesn't take you much practice to tighten that up again and get working again. The last one I'll mention is being scared of spiders. So that's like your emotion system. It's a structure in the brain called the amygdala, and it's kind of like a detector of like bad situations. It does not forget. Because if there are really nasty things out there, that's important to memorize. And you can tell it doesn't forget, because the only way to overcome your phobia of spiders is to actually try and overwrite that memory deliberately. So this is called progressive desensitization, and you'll sit there with your therapist and they'll give you a toy spider and put it in your hand. And, see, that's not so bad. That's not so bad. And then we'll get a tiny little spider that's alive, put that in your, that's not so bad. You are trying to overwrite deliberately that memory in the limbic system, the emotion system of the brain, because otherwise, if you don't do that, that memory is never going to go away. So different brain systems, different memories, they have different ways you learn and different ways you forget.
So if I was to sum everything up, because I read the first half of the book twice, just to really put some thought into this and think about, what am I going to ask? What do I want to really get from this? The basics of neuroscience, to sum this all up, is that you want to help those teachers in the classroom to understand how our students' brains are working, how their sensory systems and their emotions, how their social systems are working, make them curious, so that they will put the work in and think and learn. Have I got the first part of the book pretty much in? Okay. And then, if thinking is so difficult, because this took me 2 reads to really pull this in, and I'm pulling in Daniel Ansari, and then there's Mary Helen Immordino Yang with her "To Feel is to Learn." What else can we do to make learning easier for our students?
Well, we talked about getting the priorities right, making sure the environment's right, the emotions are right, the social's right. That there are, as you understand more about the mechanisms of learning, there are some kind of techniques that will improve. So, using concrete analogies to get abstract ideas across about practicing retrieval, about working in groups of explaining concepts to each other. And so there are various kind of techniques that will help with learning. You didn't get to the end of the book, so I can't. I have to keep some of it mysterious. But I will tell you the final paragraph, which kind of summarizes is where we're at. That as scientists, we believe we are subservient of trying to feed in the experts in the classroom, who are the teachers, right? And already a lot of what teachers are doing is the right stuff, and a lot of it already works. But the final message that we finish the book on is, just because something works doesn't mean you won't be able to improve it by understanding more about how it works. So we're not saying there's a revolution here, but we are saying a lot can be improved, maybe by a little bit, maybe by a lot, if we're understanding why it works when it does work.
Well, Michael, I want to thank you so much for taking your time to come on the podcast all the way from the United Kingdom and sharing your neuroscience, the basics, with us. For people who want to purchase the book, is the best place to go to the link from routledge.com. I'll put that in the show notes. Is that the best place?
Yeah, for sure. I'm sure Amazon will have a few copies.
Got it. Yep. Got it. And if people want to reach you, is there a website that is the best place for you?
Yeah, just drop me an email, or go visit the Center for Educational Neuroscience website. We also have a YouTube channel. So if you're interested in some of the new research, we have seminars every week, and those go up on our YouTube channel afterwards. So you can go look at the kind of cutting edge work. But also we have a blog on our website, and feel free to drop me a line as well.
Perfect. I'll make sure I put all those links for people to reach you. And thank you so much for your time today.
Thank you so much for inviting me.